Lesson 9.4, Inverse Matrices. Before we can talk about inverse matrices, we have to talk about the identity matrix, which we call capital I. What it is, it's a multiplicative identity, which means if you multiply it by another matrix, you just get the other matrix. So A times I is just A. And if you multiply a matrix by its inverse, you get I. So that means I is similar to 1. 1 times the number is just the number. If you multiply a number by its reciprocal, you just get 1. However, to have an inverse matrix or an identity matrix, you have to be square. So both A and the inverse of A have to be square. So the identity matrix looks like this. Notice the downward diagonal is a 1, everything else is a 0. Or, like that, downward diagonal is 1, everything else is a 0. Or, downward diagonal is 1, everything else is a 0. Could be any square size square matrix. Downward diagonal has to be 1, everything else has to be a 0. To find the inverse of a 2 by 2, use the shortcut formula. If A is A, B, C, D, then the inverse of A is 1 over AD, so that's the down diagonal minus the up diagonal, AD minus BC. And then notice the down diagonal trades places, the up diagonal has negatives. So it's 1 over the multiplying times the mixed up matrix. The mixed up matrix, down diagonal trades places, up diagonal changes signs. So let's find the inverse of this matrix. So it's 1 over the down diagonal, so it's 1 times 4 minus the up diagonal, negative 2 times 0, times the mixed up matrix. So the downward diagonal trades places, so the 4 is up there, the 1's down there. And the up diagonal changes sign, so it was a negative 2, so now it's a positive 2. It was a positive 0, so now it's a negative 0. Of course, that's the same as 0. So it looks like I get 1 over 4. And so now we just have scalar multiplication, so just distribute. So I'll have 1/4 times 4, 1/4 times 0, 1/4 times 2 is a half, 1/4 times 1 is 1/4. And that is the inverse. If you were to multiply the original with its inverse, you would get the identity matrix. To find inverses other than a 2 by 2, it's a bit more complicated process. You augment the matrix with the identity matrix, and then we use Gauss-Jordan elimination to turn the original matrix into the identity. So you have the original augmented with the identity. We use Gauss-Jordan to turn the first part into the identity, and whatever is left on the other side is the inverse. So let's find the inverse of this matrix. And we start by augmenting it with the identity matrix. So that goes 1, 0, 0, 0, 1, 0, 0, 0, 1. All right. We already have a 1 in the top left. We want to put this in reduced row echelon form. We already have a 0 there. So we need to turn this negative 3 into a 0. So I can multiply the top row by 3 and add it to the bottom. Top row will stay the same. Second row will stay the same. Third row becomes 3 times 1 plus negative 3. 3 times 2 is 6 plus 4 is 10. 3 times 3 is 9 plus a negative 4 is 5. 3 times 1 plus 0 is 3. 3 times 0 plus 0 is 0. 3 times 0 plus 1 is 1. All right, now let's turn this 10 into a 0. So I can multiply the second row by 10 and add it to the third row. The first row will stay the same. The second row will stay the same. I am changing the third row. So it's 10 times 0 plus 0. 10 times negative 1 plus 10 is 0. 10 times negative 2, that's negative 20, plus 5 is negative 15. Then I have 10 times 0 plus 3 is 3. 10 times 1 plus 0 is 10. 10 times 0 plus 1 is 1. All right. Now, that's going down. Let's consider working our way back up. So let's turn that into a 0. Well, this one might actually take some multiplying of 2 parts. So let's say we multiply the 15 by negative 2, and so let's multiply the second row by 15 and the bottom row by negative 2, and then add the bottom to the second row. Top row is not changing. The second row is, but the bottom row is not. So we'll have negative 2 times 0 plus 15 times 0. Negative 2 times 0 plus 15 times negative 1. We'll have negative 2 times negative 15, that's 30, plus 15 times negative 2, that's negative 30, so it's 0. Negative 2 times 3 plus 15 times 0. Negative 2 times 10, it's negative 20, plus 15 times 1 is negative 5. Negative 2 times 1 plus 15 times 0 is negative 2. Okay. Now, let's get a 0 up here. So let's multiply the top row by 5 and add the last row, to it. So I'm changing the top row. The second row stays the same. Bottom row stays the same. Top row becomes 0 plus 5 times 1, 0 plus 5 times 2, negative 15 plus 5 times 3, 0. 3 plus 5 times 1, 10 plus 5 times 0, 1 plus 5 times 0. Getting there. We have one more place to get a 0. We want a 0 right there. So what could we do to get that? Well, we could multiply the second row by 2 and the first row by 3, and that will give me 30 and negative 30. So I'm going to add the second row to the first. So the first row is changing again, which means the second row stays the same, and the third row stays the same. First row becomes 2 times 0 plus 3 times 5. 2 times negative 15 is 30. 3 times 10 is 30. You get 0. 2 times 0 plus 3 times 0. 2 times negative 6, that's negative 12, plus 3 times 8 is 24. Add those, you get 12. 2 times negative 5 plus 3 times 10. 2 times negative 2 plus 3 times 1. It's negative 1. All right, now we have all the zeros we need. Now we just need to get the 15s turned into 1. So I'll multiply the top row by 1/15, the second row by negative 1/15, and the third row by negative 1/15. So all the rows are changing. So negative 1/15 times 15 is 1, then the zeros. Then we'll have 12 over 15, and then 20 over 15, and negative 1 over 15. The second row will be 0, 1, 0. Negative, that'll become positive 6 over 15. It's become positive 5 over 15, and become positive 2 over 15. Third row will be 0, 0, 1, and then negative 1/15 times 3 is negative 1/5. Negative 1/15 times 10 is negative 2/3, and then negative 1/15. So this is the answer. That's the inverse. 4/5, 4/3, negative 1/15. 2/5, 1/3, 2/15, negative 1/5, negative 2/3, negative 1/15. You can use inverse matrices to solve systems of equations. To do so, start by writing the system as matrices. And you'll have a matrix A, which is the coefficients, times a matrix X, which is the variables, equals matrix B, which is the constants. So we cannot divide by a matrix. So that means we're going to multiply both sides by the inverse. And I want the inverse by the original because remember, the order you multiply is important. So I put the inverse at the left side of the left side. So it'll also have to go on the left side of the right side at the beginning of both sides. Well, the inverse times the original is the identity matrix. And the identity times any matrix is just that matrix. So it really comes down to multiplying the inverse of a matrix times the constants. So let's use an inverse matrix to solve this system of equations. So we have the coefficients 2, 3, 1, negative 4 times the variables x, y equals the constants 0, 7. All right, I said we just need to take the inverse of the coefficients and multiply that with a constant. So let's find the inverse of the coefficients. Now this is a 2 by 2, so we could just use the shortcut, or we could, let's just go ahead and do it the long way, just to practice that, putting it into reduced row. So I have the coefficient matrix augmented with the identity matrix. Let's turn that into a 0, so I'll do negative 2 times the second row. Top row stays the same. This comes 2 times negative 2 times 1, 3 plus a negative 2 times 4, 1 plus negative 2 times 0, 0 plus negative 2 times 1. Then let's get that to be a 0. So I could do negative 3 times the bottom row and 11 times the top row and add the bottom to the top. So I'll get negative 3 times 0 plus 11 times 2. Negative 3 times 11 plus 11 times 3, so that's 0. Negative 3 times 1 plus 11 times 1. Negative 3 times negative 2 plus 11 times 0. And then the bottom row stayed the same. Now I have the zeros, so now I need to get the leading ones. So I'll multiply the first row by 1/22. The second row I'll multiply by 1/11. So 8 over 22 is 4/11. 6 over 22 is 3/11. 0 times an 11th is 0. 11 times an 11th is 1. And I have 1 over 11 and negative 2 over 11. So that is my inverse. To solve this system, I simply take the inverse. It's going to go first. And multiply it by the constants. So I'll do the first row, first column, so I'll have 4 times 0 plus the 3/11 times 7. So that's 21/11. Then I do the second row. I'll have 1 times 1/11 times 0 plus negative 2/11 times 7. So that's negative 14/11. So still the xy. xy equals 21/11, negative 14/11. So that should tell you right away that x is 21/11, y is negative 14/11, and that's the answer to the system. Of course, you could have found the inverse shorter using the shortcut given earlier in the lesson.